So this talk is kind of about scaling our code base from a hacky project to a professional product. And it's something, like Rachel said, I could have benefited from a while back as well. And just a quick introduction. So this is my GitHub account. First thing I say, it's like my GitHub is a graveyard of side projects. And before Voiceflow, I've done a ton of different projects ranging from, I made this like browser airdrop thing where people could like, as long as you're on the same IP address, drop like files to each other. I made a Reddit clone called Stack City, and I'm getting like 100,000 users at peak, and it kind of died. Like I made video games. This was like a zombie shooter a while back. I made a SaaS application for Model United Nations. It's like really niche. I made asteroids for Ubisoft, and like I've done everything like a little bit in between too. And before we get started, I'd like to share one of my favorite memes as well that kind of defined a lot of my journey as a developer. So if everyone's familiar with the Fibonacci sequence, this is like, the standard way you'd kind of do it in programming. This is like a recursive method. Cool, CSC 101 student. At a hackathon, it's a lot more improvised, obviously. It's a lot of just a little more deterministic. And, at a startup, things become a little more hectic, a little crazy, and a lot of things are happening. And finally, the last step is this is what it looks like at a large company. And we'll talk a little bit about how I went from like this stage eventually to here, the code we have at a startup, and how I ended up here. So I'm going to try to convince why this is good, but maybe not for this particular use case of Fibonacci sequence, but kind of why some of these patterns are good. So like I saw someone say they were going to build a Tinder clone, which is exactly what I have. There's so many of these like side projects. I know this myself because I built a Reddit clone. And sometimes I feel like I've gotten maybe 80-90% of the functionality that Reddit has. I've built it out. I have the core functionality out there. So what is actually the difference between my code base, the code I'm writing, and what's happening in Reddit or what they're doing? Like it was really opaque for me back then when I was a high school student to understand what professional code bases are like and why they are a certain way and why they are the way they are. And yeah, the journey there, and I want to talk a little bit more about that. So actually, before we head off on Voiceflow itself, we'll talk a little bit more about Voiceflow here. So we're basically a company of almost 40 people now, and we've been around for 3 years, based out in Toronto. We essentially let people build chatbots or applications. Well, you can design conversations, right? The same way you would design like a website, you're able to design a conversation and kind of build out conversations. So that's what we let people do. So it's almost like a little graph that you're able to plug some lines in and then eventually build out like fully fledged conversational AI. So this gets used from like car assistants to hospitals to Barbie toys, everything else in between. So it's definitely a fun space to be in. We actually started off as a children's bedtime stories company. So as you can see down here, we made like interactive children's bedtime stories. So parents could outsource their bedtime stories to Alexa. And we ripped off a lot of like titles. So Dragon Trainer and Wizard Quest, you can probably assume they're inspired by certain IPs. And now this is where we're at, a little bit more mature as a company. We have almost like 155 repositories. The team's grown a lot more now, and we've open sourced a lot of our code, and finally it's good to show it. And the project itself has matured a lot in the process. So with this talk, I want to talk about why there's so many frameworks, so many tools, especially in the JavaScript community out there. Like there's so many different logos you have to keep track of. Every day there's like a new JavaScript framework, right? And here I'm trying to convince you why it's important to learn these things and why they are beneficial and why they're useful, and kind of the progression you might need to kind of eventually reach these things, and why it'd be really useful as well. So this is more tailored towards people who are more new to the community, or they're doing their own projects and haven't really started off in like a full enterprise workspace or anything like that. But also for like seasoned developers, hopefully there's something useful in here for you as well. So it's not that I never tried enterprise like code bases. Like I had internships where I worked with larger code bases as well, but I got told to write tests. I did things in a certain way, but I just did them because I was told to do them. I didn't feel like it was a good thing that I was doing. I didn't understand why I was doing them. I was supposed to write tests, or I was supposed to write these patterns, or I had to do these abstractions, but I, like, at my heart, I didn't understand why. I just wanted to move fast. And as a developer, when I first discovered JavaScript, up until then, I've been learning like Java, C, and all these things in school. They're very rigid languages with very clear syntaxes, types. And when I found JavaScript, I was in love. I was like, this is so easy. I can just, a variable could be anything. Like it's perfect. And then I don't have to declare anything. I can just hack away so many frameworks, just throw them together like overnight. It was like a beautiful thing. And that's kind of what initially drew me to JavaScript. That's been my like language of choice since then. All right, so this is kind of a little meme about JavaScript as well. So I don't know if I'm clear of like Christian theology as well. Essentially, there's like, it's monotheism, but there's a way that there's like three. But yeah, so this is kind of what JavaScript looks like too. If you actually try these things in your console, it will be true. These are equivalent here. So to start things off, I want to share some snippets from our early code base just to show everyone what it looked like and kind of how it's changed over time. So if you saw Voiceflow earlier, you'll see that we have different types of blocks, right? And this is one of our earliest pieces of code. We had a gigantic if-else statement. This entire file is just if-else statements for every single type of block. It's one giant do-while loop. And then within a loop, you know, if this is a random block, perform the random block stuff. And then otherwise, if this is the set block, do this stuff, or like, this was like the entire file, right? Just the if and if-else statements all the way down. And our early code base, to like our credit, we built it so fast. Like the initial MVP, like we did it overnight almost. And it was like, in these early days, we could push out a feature like every day. Like you come up with something in the morning, you just think about it a little bit and you like hack it out really quick and come back out on the other side. For the front end devs here, like we didn't even know that Redux existed. We drilled props like 10 layers deep. You just like pass data down the props and like back up or something. So there's a bit of a Wild West out there. What else do we have? This algorithm's a little crazy too. Shunting yard and some of these other ones. So this is kind of the idea of what the code base was like in the early days. And you can tell by my YOLO push commit, it was very out there, kind of do as you would deal. And yeah, and that's kind of how things started off. But a lot has progressed, and I'm going to kind of share each of the individual steps that have really helped shape our code base now over the past 3 years and my learnings from it. It was because I did things this way that I finally understood why. It was like a coming of like knowledge or a coming of age thing for me, like as a developer, to understand. It was only because I wrote bad code in the beginning like this that I understand why we have to do these patterns later on. I had to clean up my own mess as well. I refactored everything in here. So that same if-else statement that we saw earlier. So I'm going to open this link here. So let's just take, for example, down here, this random line. So this is a giant file of if-else statements, right? And this logic specifically within these lines are here to handle the random block. Instead, what it looks like today in our open source code base is there's now a specific handler just for the random block. And here it's called the random handler. It has like a defined structure. The code is done here. And then along the random, every other block type has its own little handler. They're separated out in different files. And we have an overall handler structure that kind of finds the handler for the next block and kind of fetches it. So this is a little more abstract. It's out of the way. It's not as, maybe it's easier to read if it's just if-else statements, but because it's broken up, it becomes easier for more people to work on and manage as well. Great. Also happy to kind of answer any questions along the way. Feel free to drop them in the chat. I'll be looking. Thanks. This is a tech stack about Voiceflow, so very JavaScript heavy. We do NodeJS in the back end, React in the front end, and everything's TypeScript across. So the benefit of that is also the front end and the back end can share libraries, which is kind of neat. we don't have to spend too much time here. So throughout this topic, I'll kind of talk about different concepts or ideas, at least in my own philosophy of coding. This doesn't represent everyone at the Voiceflow engineering team, but it's things that help me work out. So efficiency is not everything. So if we look at this past, like if you think purely in terms of computer science, like if else statements are faster to evaluate than functions, right? It's like if you're calling functions and functions are calling other functions, technically if you just do one, this file is more efficient than we have right now. It's true because it's just, for the computer, it's just looking at the, if statement, instead of like, calling arrays, calling keys, and kind of trying to match things. Good code will often be self-documenting. A lot of the code we have today, there aren't that many comments because it becomes easier to read as long as you name your functions and variables the right way, and it's very transparent. You actually don't have to add nearly as many comments as you think you would. It becomes easier to kind of trace things around. And you can, so like this statement down here is something we have in our code base today. Like, is it very readable? Like, is it very clear what it does? Hopefully. Like, we're fetching a transcript, and then from the transcript, we're fetching the project that the transcript's attached to. So we're getting these things out from it. This could be one SQL statement. So instead of having these two separate ORM or like object relational model things, this could just be one select statement in SQL and where we join the tables. This is more readable just because we're making two additional SQL calls. The penalty is a little higher from purely the computational side, but if you're able to read it better and it's easier to work with, I think it's worth that penalty. And eventually, for the maintenance of it, it becomes kind of, I think it pays for itself in terms of the maintenance of it. So basically the point I'm trying to make here is it's okay to forego the most efficient code ever for something easier to maintain. So it's okay to build layers of abstraction. It's okay to build functions, especially JavaScript, because like it's very lenient, it's very high level. It's already kind of not efficient in the first place. Like if you think about it, for anyone who knows like the pattern of immutability, it's actually technically not the most efficient thing. If you actually mutate the objects and everything else, instead you're not creating a new object in memory every single time you're like passing things around, it's faster technically. But immutability is a concept that kind of helps maintenance and bugs that really pays off in the long term. And that's kind of getting around to in these patterns. So immutability and understanding side effects in the data flow is really important as like a developer. So at a very abstract level, all you're doing with code is you're kind of like flowing data around. You're passing data from one function to another. You're modifying the data maybe, and then you're passing it from another function to the other. So sometimes the data is going into a database, sometimes it's passing through APIs, but ultimately you're kind of just passing data around, right? So it's important to understand where this data is coming from, where it's going to go, and what's happening to it in between. Essentially, that's kind of everything's happening. That's everything that's kind of happening within like any programmer application you work on. Abstraction is kind of a buzzword. It's like when business people say like synergy, like for programmers, but knowing when to abstract is very important. Knowing when to break something into different functions is really, really crucial. But if you do it in the wrong way, it's actually even worse than just leaving it as like a giant blob or something. It's knowing when to abstract things and pull stuff into a different level. So in React, this might be taking out a state of an object and putting it into Redux or into a context, and knowing at what level that context should live and exist. And knowing this is something pretty important. Another pattern that's going to be really useful, I didn't see it at the first, I didn't understand it initially, but having small files that are not over like 300 lines of code is very good. Maybe on the higher end, like 500, but like ideally aim for something in the at max like 100 range, because it's really easy to consume these small files and it's readable. Kind of like the code I showed earlier here. Like from all the functional things are from line 10 to 58. And like within that, you're able to kind of just, it's a lot easier to process and you don't have to dig through a file every single time. Instead of navigating through a file that's like 5,000 lines, it's easier to kind of look through your file structure and find the right file that way. Yes, and it becomes easier to kind of maintain and merge too. So whenever you have a large file and someone else on GitHub might try to merge something in there, it's gonna like blow up a little every single time because you might make big differences or like there's a lot of changes in the file. Yeah, and I think one way you can think about when you make something or whenever you're creating something, even like a portion of it, could I just take this code out and put it into an npm package and open source it, and someone else would actually find it useful. That's a good way to think about your code. And if you can break it up into a package that's actually useful, it's an actual utility or it's a library or something or a component that could live by itself, then that's kind of you're doing things the right way. If everything's so tightly coupled that it's impossible to break apart from your app, then maybe it's like too rigid in a certain way. So that level of abstraction is kind of really a good way to think about things. Like whenever you think about the packages that we use or we consume, like it's very well defined what parameters it has, what should go in, and it's kind of like self-functioning, kind of that module by itself does everything it needs to do, rather than kind of being coupled or like this data there is like linked over here. And it's really opaque to see how everything's traced together. Another tip, I guess, for people is, I know like it's kind of a meme now to like do leak code and that type of thing, but learning data structures and algorithms is, I think it's something that is important as you progress as a developer to know at least the more core functionalities of data structures and algos. There's a reason why it's like the standard for interviews and everything else, but it gives you a bigger toolkit to draw from. So whenever you're solving a problem, maybe because you know this piece of information, it'll let you solve the problem a little bit easier, or you have something to draw from immediately. So yeah, that's definitely highly recommended. Wonderful. TypeScript. So I can't stress enough how life-changing TypeScript was for us as a company. So initially when I got like floated the TypeScript idea of TypeScript float around, it's like all that joy that I had of JavaScript of being like flexible, everything's like out there, and so okay, it's like, oh, I'm just going back to the Java thing I like spent so much time learning, and I didn't really truly like at the time. So here are the benefits of TypeScript. It works with your JavaScript projects already. So you have like an entire project, whatever it might be, it could be all in JavaScript. You can still apply TypeScript on it. You just have to change one file at a time to like from .js to .ts, and then fix some syntaxes and you're good to go. So TypeScript automatically compiles down into JavaScript. It's like a superset on top of JavaScript. So it's not like a whole new language or anything. Because all TypeScript, it just becomes JavaScript. If you just remove the types, it's pretty much pure JavaScript.
It is. Sorry.
What's up?
Sorry.
Sorry, I can't. You're breaking up with it here. What is it?
I didn't mean to say anything. Sorry.
Oh, okay. Yeah, no worries. TypeScript gives you autocomplete, right? So it allows you to, let's just find some code here. When I type program, I know exactly what is going to come next. So I can get commands. And from the commands, I know like having every single piece of information like there, like it's possible in the beginning of early stage projects I think for me, when I start projects, it's easy to know where everything is. Like when you personally do a thing, you know exactly where each line of code is, what each variable is going to be at any point in time. But as the code base expands, that's not always going to be the case. You're going to lose track of things. It's going to get like people are going to work on other parts that you don't realize like what's happening over there, and things are going to get changed. So this is a way, like it's like a mutual handshake, right? Everyone on the team knows that this variable is going to have this value, and you're not going to get any surprises. It saved us a ton of errors in the future, because like how often in JavaScript does values undefined or like this doesn't exist, calling like this property of this thing doesn't exist happen, right? And so often a lot of this just gets prevented by TypeScript as well. It gives people a faster way to understand and gain context on certain areas of code that they normally wouldn't work on. And of course it's managed by Microsoft too, so it's well maintained, and it's become the standard kind of in the, I guess, professional JavaScript industry. Linting is also very big, very big. If you don't have a linter yet, I definitely recommend checking out ESLint and setting up some configurations there, or you can even use the Voiceflow linting configs that we have. It's also open source. So what is linting? It forces your code to behave in a certain way. So if I actually try to move this line of code down here under the export and press save, it's going to put it back there again. I'll try that again. It will just not let me do anything else. It forces you into a certain framework, and also just tells you when things are going to be wrong. Like, so if I call like, it'll tell me that, you know, nope does not actually exist on this type. Linting, that's more on the TypeScript end, but linting kind of, it's a very opinionated way of telling your code what it should and cannot do. If I actually declare a variable here and I set it to 0, it will actually get mad at me because this variable was never used. Just these little things that it's able to detect makes your life overall easier. So you don't have to think about these things. It catches all the errors where like things are going to be undefined or they're getting used before they're being declared, and just things like that. And the most important thing for linting too is that it standardizes your code base. In the ideal world, so we got Josh here on the team as well. Like, I don't want to know whether Josh wrote this or Liart wrote this, like, or I wrote this. Everyone's code should look more or less the same. I don't want to go into one section of the code base and suddenly see this looks drastically different because like this guy's got a little bit of flair in his code and he likes to write it this way, or like this other person likes to write it that way. And then every single day when I look at this part of the code or that part of the code, I just have to shift my frame of reference. Everything's just consistent. Like when you go look in one place, you know what it's going to look like. You go looking at like a totally different part of the code base, you also know what it's going to look like. It's going to look the exact same way. It's going to be formatted the same way. Maybe a good example of this, so you can find it. If I extend functions out a little bit longer, it'll kind of wrap it around and tell me to, handle or something like that, and to string. Eventually it will like wrap it around and kind of formulate certain patterns and ways. What this also does is it prevents conflicts, because everyone's code is committed in the same way. Because my runtime, so this import package that I'm trying to get in from here, like because it always forces it into that part of the code, it's always consistent. Like there's no way that when someone else adds a package, it's not going to like delete some other packages or kind of mess up my import order. It's always the same way. And if I look at somewhere like different part of our code base, so this is the front end here. So let's just dig through around here. Let's just nope, index. Let's see, page. Let's go to our routes. It's a larger one. Just digging around here. Like as your import statements become even larger, you can see kind of how it's important to have these in the right order so it doesn't mess it up in any way. Great. So that's kind of linting. It just takes your code every time you press save, or like you can set it on like certain occasions, it will format it. So it'll format it to exactly how you specify it. So there's these ESLint files that you can configure to be as strict as possible or as lenient as possible. But it also just helps you catch errors along the way. So linting is kind of very essential, I guess, to maintaining clean code. Testing. So I actually hated testing when I first started off, like having to write tests. The first thing I did as an intern was write tests. So that was my onboarding. It's like, hey, Tyler, your entire day today is just writing tests. Okay. Tests don't matter nearly as much on a smaller code base when you know everything, where everything is happening, but tests kind of allow you to capture any changes in the code that are unexpected. It's also possible to do test-driven development where you write the test before you even write the code that you, like the functional code for your application, so that you kind of set out a list of parameters that your app should be doing or this function should be doing. And then when you actually write the function, you just make sure that it actually fills out the parameter, all these parameters that you set previously. That, like you can set out all the goals and objectives for a thing in a test. And when you actually write it, you're able to see if it functions or not. It's easy to test edge cases. It's easy to, especially when there's side effects. So side effects is when you might change one part of the application and something else entirely like different suddenly like breaks or something happens there. Like this allows you to capture that. There's like parts where the logic might be very convoluted and it's hard to trace and to know which part is where something is relative to something else and kind of what triggers what else. So tests help capture that. And there's different levels of tests and there's different categorizations. This is just a small subsection. Unit tests are tests that are just mostly centered around functions or like smaller units of code. So it just tests them individually by themselves. Integration tests kind of pull in things like the database. You start using more, like a lot of functions in sequence, and you're actually writing to a like test database, or you're kind of trying out saving data and kind of figuring things out there. Snapshot testing is an interesting concept. It compares, like we had a snapshot test that compared like the front end. So it would take a screenshot or like it'll look at the code rendered for React on before like my commit and then after the commit, and it'll see like what actually changed in there. And basically you have to verify that like these changes are expected or they're not expected. Because I changed the CSS here, it shouldn't change the CSS there, right? That type of deal. And end-to-end tests are the most comprehensive ones. The tool you'd use for this is something like Cypress. It tests your whole app from beginning to end. So what's really cool is we can actually watch an end-to-end test here. I will kind of pull up a thing. Let's look at our latest commit here and let's look at the end-to-end test. Nice. So what it's actually doing, we'll watch this MP4 file really quick. So this test is, it makes sure that the canvas opens properly. It'll pretend it's a user and kind of click around and do everything. Everything's linked up together. This is all automated. I'm not touching it or anything. This is just testing that you can open the settings page and it works fine there. It's basically running through all these flows and it's verifying that it all works in sequence and in conjunction. So that in itself is very useful. So I guess a more practical example here is the payment flow.
And at what point do you decide, like when to create these tests? Like when you have, like, for example, a proof of concept, like it's generally more suited for unit tests, like when the whole project is smaller. I'm finding that like, integration and end-to-end tests like happen when you have a more full-fledged kind of flow, like an actual behavior-driven user flow.
Yep. Certainly. So this example of like a really important end-to-end test we have here is payment. It's just making sure our payment works every single time. Like you can see it's entering a fake credit card number and testing under like every single circumstance that the payment's going to go through, or we don't change anything that breaks it. Even though we have unit tests covering this, it's important that the overall flow kind of works there. Yeah, it really depends on the functionality of what you're building and the particular feature that you're working on, where like you might want an end-to-end test versus doing unit. Sorry, that wasn't a very good description, but yeah, it's like a case-by-case basis, because end-to-end tests do cost a lot more resources, and it's something to consider as well.
Yeah, just related to that, like, so do you run these end-to-end tests on like every like commit basically, or is it like certain commits, or how do you do it? Because they are like expensive.
Yeah, so right now we are running them with every pull request. So like your end-to-end test needs to pass before your pull request can get merged in. And it runs on the master branch of every single major repository we have too, just to verify like anything that you change there won't break anything else in another component. Yeah, so as you can imagine, each of these tests, it's like actually like you're renting a computer basically, and it's like opening a browser and it's like pretending to be a user that like tests and clicks things around and verifies everything that works. So it's not terribly cheap either. So yeah, that's kind of yeah.
Just one question around, how are you testing across the browsers? Are you just doing targeting Chrome or other browsers as well?
For now, we're targeting Chrome because that's our main support. I think in the future we'll expand to do more other browser testing as well. That's a really good point.
Okay.
Yeah, like honestly, some things genuinely might look a little different on Safari that we don't necessarily account for, but all our designs, kind of everything is mostly centered around Chrome. For now, I think the best way we approach that is we just have team members that use different browsers, like just by preference. Like some certain team members want to use Safari, some certain ones use like Firefox, others use Chrome, and like their development process. because it changes hands, because other people review it, you're able to kind of capture anything that might get missed there. Yeah. This isn't necessarily something you would do with your code, but it's kind of automating things around yourself. So every developer has their own preferences when it comes to productivity hacks and, you know, optimizing your setups, things to make your life a little easier. For me, I have like a crap load of aliases. This is just a small section of it. So all my Git commands, instead of type, just so I don't have to type git pull, I write GPL, right? Like not typing those extra letters does make things a little faster. All the most common commands I use, I have an alias for. Some people like to use like crazy ergonomic keyboards, or like they use like Dvorak or like some other keyboard like configurations. Other people have crazy monitor layouts. I know one member of our team has like 4 monitors at least that they use. For me, like some tools that I found that really helped me is learning regex. It's a bit of a commitment, but getting good at regex becomes really useful when you want to like do global search and replaces. So like I want to replace every instance of this word when it's followed by this function doing this thing like with this other word. And especially in the stuff we're doing in the voice space too, it's really useful to know regex so you can extract certain words out of a sentence that you might need. Yeah, maybe it's something like committing to Vim, learning a little bit of Vim. So in your console, you can make quick changes without having to boot up an IDE. There's these like little things. You don't have to like go through all of them, but just, I guess there's always these little hacks that you can use to kind of help yourself as a developer boost your productivity. Because ultimately we want to be lazy. We want to automate as many things as we can so that you don't have to do like repetitive or like maniacal like kind of chores, essentially. Try to find things in your life that like you find kind of annoying when you code. Maybe it's formatting, like linting kind of is a way of automating your like cleaning your code, or committing, or like even continuous integration is a way of automating things. So instead, in the early days, I'd like go SSH into a server and write git pull and then run node. And that was pretty much our entire flow. But now it's automated, right? I don't even have to go SSH in a server. I just deploy to master. As long as my code gets merged in the master branch, it'll automatically get pushed, like queued up and pushed to production. So it's a continuous deployment type thing. So automating these things is very, very useful. Great. And the newer concept that's been around now is called feature flags. This is more, again, for like larger code bases, but I don't know if anyone has had the experience of doing large feature branches. Essentially what happens is, say I'm working on feature A and my friend like Winston is working on feature B, and feature A is a huge feature. I've written like, I don't know, like 50 files already or something, and Winston's written like 50 files too, and he's going to merge his branch in. And now all my 50 files need to get changed, rebased, or merged with his stuff. And maybe my feature is like ongoing development, and I still write like another 100 files or something. Every single time something new gets added to the master branch, I have to keep updating, like perpetually updating my branch, and it'll just keep getting bigger. And also it just becomes hard to review. Like when I open a pull request and it's like a few thousand lines long, it's very hard to read. Like no programmer is going to be able to sit through that and like understand every single line like meticulously and know exactly where everything is. So feature flags are really beautiful. So what they let you do, so here in React is a good example. You know, if this header redesign is enabled, we'll show the progress bar. If it's not enabled, we'll just use the original like code there. What this lets you do is kind of push code that is not ready into production or into your master branch, but have it hidden behind a flag. So you can have a lot of work in progress things, and you can have your feature half built out and still have it merged. So you can start merging your feature into chunks, right? So you can do the first 10% of it merge into master, and like the second percent. And like, it's really easy to kind of merge these little chunks in without having to go through the entire process and kind of throw yourself at it there. I was seeing a question on Cypress. So another comment on Cypress. Yeah, so what we actually ended up doing is not on every commit. It's only when someone's ready for review and it's ready to be merged. You can actually press approve in Circle CI to run the the ETE test. It'll run, so yeah, every person, like you would have to actually like decide, I want to run the ETE test on my branch now, it's ready to go. Then you'd approve it and then we'd send it through. So that's kind of how we've constructed to try to keep costs down. We did it on every commit and we got hit with the Cypress bill. Sorry, the Circle CI bill was like $19,000. So that was not fun. Yeah, so things are a little better now. So yeah, feature flags, hopefully this makes sense. You're basically just, and on most feature flag programs have a dashboard where you can kind of enable and disable. So the really neat thing is, like for us, I want to show some secret features, I guess, that are kind of on the roadmap here. This is what feature flags look like. So here you can see that we have a new feature coming out. Let's call it real-time connection, or maybe there's a different one. Trying to find topics and components. This is a big feature we're working on. So only show it for these people and only show this feature flag here under this condition. And then like I could just press this one button and turn the whole feature off or turn it in. Like this allows you to kind of do A/B testing as well. It lets you control whether a feature should be shown or not. And it's really useful kind of for rolling things out and doing like a subsection as well. So certain people can test it. This way we can actually push code to prod and test it first in prod with our own accounts before rolling it out to the rest of the user base. And then once you're done everything, you just, the code is so easy to remove. Like here, I just delete this line and delete that and I just keep the progress bar. And that's exactly kind of where we ended up.
Exactly. How are you doing feature flags on the backend side?
Yeah, we're using this program called Unleash. So it's like a managed service, or you can host it yourself, where you basically call it and see like, is this feature enabled? Because I am user X and I am in environment Y, and I want this feature. Is it enabled or not? Actually, like a good way to look at this here. If you go on Voiceflow today, if I go look in the Redux here, you can actually see we have our feature flags here, and you can see what features I have enabled and which ones are false. So you can see I have project versions enabled, but I don't have enterprise trial enabled. So it's fetching these through an API call and the page loads, and then it bases its like a composition off of that. So Victor, good question. So this is exactly what feature flags try to address. Because you have these new features that might be really big, instead of trying to merge them all in together at once, you want to merge them in pieces. Even though it's not complete and might not even be functional, you can still merge them in with pieces with feature flags. So because it's behind this flag, you will never see the rest of it. No user will actually see it, but it's already part of the master branch. Yeah, so Unleash is one of them. There's a lot of other options too. So I'm not like, this is not endorsement or anything. Like it's very commoditized. It's a very simple idea. You can build your own feature flag system if you want. You can make your own feature flag company. It's basically like, hey, can I use header redesign? No? Okay, I can't. That's pretty much it. It's just like managing it, like having a little dashboard to kind of manage your features. Backend, it's a little easier than front end to manage features, because you can just you can create new versions for your API or create endpoints essentially. So you might have like a V2 endpoint instead of like the original, or V3 endpoint or something. So that's kind of how you version or feature things in the backend. Yeah. Wonderful. Continuous integration. So kind of these are the processes that we've added in to kind of make sure that, the CI/CD, the pipelines things are easy and consistent and we don't run into bugs. So we follow like a standard Git pull request workflow. So you need at least one person to review your code and approve it to be able to get it merged. It needs to pass all the tests. It needs to pass the linting. It needs to pass the build. It needs to pass the ETE. Then we have like a quick hack too is like having a pull request template. These are things kind of built into GitHub. So every time I start a pull request, it'll actually kind of have a pre-built template and I just fill it out. Yeah, we can do that really quick here actually. So let me added a comment here. Great. It's a huge feature push. But here I will check out a branch. So I have my alias here, and then like Tyler. We also have some conventions for branch names too. Call this cool feature, and I'll add all my stuff. I'll write a message. So this is the kind of the normal workflow. If you have a feature kind of at Voiceflow, what that would look like. I'm going to do git push. It's going to tell me I need to push to a branch upstream. Okay, push. I have this really neat alias called GH. It just opens the, I open it in a different window, but it opens it up. So when I actually make this pull request, I actually have a template here. It just has everything I need to fill in. What does this change? Which ticket in Jira does this address? What are my details, any deployment notes, any other related PRs that I need to do, that type of thing. So this standardizes the process, and I would add a label, like ready to review. So another dev on the team, also it's possible, we do like a randomized selection too for who should review something. So I actually just go creator team and I type that. It's going to pick someone random and message them on Slack and kind of tell them, you should review this. So it's impartial to kind of who should be doing it. Yeah, so that's kind of a fun workflow. It's important to make sure that your test coverage doesn't decrease either. So every PR you're adding or anything you do is increasing your test coverage. You're not regressing in your test coverage in the process. And basically how we work is when something gets merged to master, that is the same as production. Like that is as good as being on production, and it'll get pushed out there. Yeah. Another neat thing is cloud environments too. Like if you assign a tag on GitHub, it'll kind of create a new environment just for your pull request. And then you can send that out to like a designer or someone else to look at. Also, adding analytics and monitoring to your project is really useful. So the thing I didn't add here is Sentry. But basically every time a user comes across an error, like in the console, it goes red, it'll inform you. It'll tell you that this user encountered this problem or something else. LogRocket's very useful too. It lets you kind of track a user's like flow and the most important thing when you encounter an error or like out in the wild when someone else is using your app is being able to recreate it. Like knowing the exact steps they took to get to that error is like absolutely paramount. So having logging allows you to kind of trace things back from the user and what they've done and kind of how to get there. Great. Nice. This is just an example sprint. Eventually having your tickets organized, whether you're a one-person show or like you're 40 people or like even 1,000 people, having things organized into like a Kanban board is very useful, or just having tickets, like knowing I need to get this done, that done, and in what sequence, if this is blocked by something else. Assigning it, having the correct labels, it's just, it's really nice for the workflow. Another thing we ended up doing that was really impactful to kind of our workflow was cloud systems. This is something that will come later on down the line for a lot of companies for sure. So like, as you can imagine, Voiceflow became really complicated. We had almost like 10 microservices. So each one is a Node.js server, right? So before, when you want to test something end to end, I would open 10 terminal windows and I would just type like yarn start like on every single one of those windows, and it would kill my computer every time. It was not fun. Yeah, so that's kind of how things were before, and that's kind of what that's kind of what you would expect to do when you start a project. Instead of what we have now is every single developer has their own developer environment. So if I actually go to creator-dev Tyler here, this is my own environment. The database lives separate from production. It's my own thing. Like it's different from Josh's or Liart's or anyone else's environment. And what it lets me do is, if I know I'm only going to work on one component of the application for this feature, like Creator API, I only have to run Creator API on my computer. It will mesh the rest of all requests to like Creator API Tyler to my local computer. So what that would look like is Creator API-dev Tyler. So here it says I'm alive, right? But if I actually run around here and in my API branch, yeah, that's good. Pop that open real quick. make a change. So it says I'm alive somewhere. We'll look for that. Cool. It sends I'm alive, but I'm presenting on Toronto.js. Whoops. And what I can do here actually is I'm going to reconnect to the CLI here real quick. And now if I run yarn local, it's going to mesh my local computer's instance with kind of what's on the cloud. So this is like a workflow tool that just saves me like, so I know my feature only relies on Creator API. I don't have to like touch any other components. I only have to run this on my computer. And because I did this, I'm gonna let it start up the server here. Now if I check back and I refresh, but now I'm presenting on Toronto.js. And then if I change anything else, you know, like add a H1 tag, have things on front end stuff. Save that. It's gonna kill the process, restart it, and then I'm able to kind of just instantly get feedback, but not have to run everything else. And that's been a big like life changer for us as well. So that's kind of how that process works. Yeah, and then communication tools, I guess, are pretty important kind of when you're working on a team. Eventually kind of figuring out your stack. Like this is what we use, but anything else out there is open as well. So Discord is a great channel to kind of find things. Jira we use for our tickets, Sketch for designs, Sketch and Figma both for designs. Figma is such a great tool. I definitely recommend a lot of devs to use it or check it out. It's really good for drawing diagrams or trying to understand like architecture and things like that. Notion for documentation. Yeah, generally stuff like that. I won't go too much in depth in that, but yeah, lastly, like just staying on top of the JS community is so crucial. Like even within our team, we have like this channel dedicated to just sharing new things that's coming out, new packages, and there's like a new TypeScript version or something else. So knowing the latest tools, frameworks, and kind of what's the buzz around, it'll just make your life easier, because maybe the next time you start your project, you'll know I can actually use this tool now. Okay, maybe I React Context is that. I'm going to use React Context. Knowing the latest and greatest is definitely beneficial, especially when things move so fast. And you get to meet amazing, really passionate people who are able to be mentors, help you get questions answered. And for those who haven't worked at like a larger company or enterprise, the closest thing without being like fully employed usually is just trying out open source projects. They're like the large ones. They're usually very clean, and being able to dig around is really valuable. Where I got a lot of my chops from learning coding was just by looking at open source projects. Like something breaks and I don't understand why it's breaking. And at some point I realized I have to go deeper. I have to like look at the function that I'm calling from this npm package and read the source code for that package and see kind of how they structured their thing. And that'll help me understand how different people use different patterns, kind of what they've decided on, why they've decided on these things, and having like a more diverse perspective on code bases and kind of how people have constructed them is so nice. And open source really emulates what we do. Like at any large company or like any large open source project has the same dynamics. You're gonna have teams of people, you're gonna have discussions about features and whether it should be done in a certain way or not. And we've always, yeah, like we've even like just hired people straight up out of open source because like even though they've had no like previous industry experience, it's something that's just as equivalent, at least in my opinion there. Great. Lastly, I just want to end this off. This is purely from the startup or entrepreneurial side of things. So you can feel free to write code, really good code out there. But I guess at the end, it's always a balance. It's not like I'm gonna write immaculate code and instantly my app is going to be a unicorn now. I don't know. He just said this like very nonchalantly. It was like a casual conversation, and like it kind of stuck with me. This is my founder, Michael Hood. He's a designer here, so I often like get his designs and I implement them. And yeah, you could have the best code in the world, but if no one ends up using it, it's also not worth it. So it's always a balance between refactoring, writing good code, and getting something out or having someone use it and actually get feedback on it and even if it's a little wonky, having something to show for it. Okay, I hope this entire presentation is useful. I kind of blew through it really fast here. Hopefully everyone learned a little bit of something. So these slides are going to be public afterwards as well. And I'm planning to there's an accompanying blog post for this too. So if you want to kind of read more in depth about specific parts of the code and stuff like that I touched on, happy to share that as well.